Hey guys. Okay, so in this video, we're looking at the hybridization sp3d2, and the example is of a bismuth pentachloride and, with a 2 negative charge. So in this case, as all the steps we have been doing in the previous videos also, we will do the same steps. So first thing is calculate the total valence electrons. And here we have 42 valence electrons. Next is draw the Lewis structures. Bismuth will be in the center and chlorine will be on the side, because chlorine will only make one bond, because bismuth is lower in electronegativity than chlorine. Although chlorine can make 3, 5, and 7 bonds, but bismuth, the electronegativity based on that, bismuth has a lower electronegativity than chlorine. Therefore, chlorine will only make one bond. If chlorine was attached to another atom that had a higher electronegativity, in that case, chlorine would have made 3, 5, and 7 bond. But bismuth only bismuth will make 5 bonds. Okay, so now we have, you put the bismuth in the middle and you connect the bismuth with chlorines. And here we have used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 have been used up. So we have 32 electrons left. 32 are going to, so remaining electrons we use to put the octet of the outer atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and the remaining go on the central atom, and that is here. Okay, so we have now all 42 electrons accounted for. So 10 in the middle with the, single bonds with the chlorine, and then the remaining, to fill the octets, and then the central on the central. Now here is how many sigma bonds? 1, 2, 3, 4, 5. 5 sigma bonds. Okay, this is making. So that's one thing. Next is the we are going to look at the electron groups. Okay, so next is electron groups. So these are the steps. First step, second step is the Lewis structure, third step, electron groups. So on bismuth, how many electron groups there are? Bismuth and each of the chlorines. So bismuth, there are 1, 2, 3, 4, 5 single bonds, 5, let's put this here, 5 single bonds and 5 single bonds, and plus 1 lone pair. So that makes how many electron groups? 1, 2, 3, 4, 5, and 6 electron groups on bismuth. Okay, chlorine on the other has 1 single bond. Okay, but it has got 1, 2, 3, 4, 5, 6. So in other words, 3 lone pairs, and those 3 lone pairs together, 1 plus 3 is equal to 4 electron groups on chlorine. Okay, so now this is related to the type of hybridization. So on bismuth, we will see we have bismuth has 6 electron groups, and these 6 electron groups relate to a specific type of hybridization. Similarly, chlorine has 4 electron groups. So these electron groups will also be specifically, specific hybridization. So as we talked about that, the electron groups and the hybridization, you have to match them. So here we have 4 electron groups on chlorine, and that is the sp3 hybridization, and the shape is the tetrahedral shape. Okay, bismuth on the other hand is showing 6, is showing 6 electron groups. So it is sp3d2 hybridization. The shape from the point of bismuth is going to be octahedral. Okay, now let's go back and put it here. So this is relates to this color, sp3d2, and this one is sp3. Now, anytime you have sp3d2, what does that mean? This means it is, it will have how many lobes? So 4, 5, 6, 6 lobes, 6 orbitals, mixing, 6 lobes, sp3, 4 lobes. Okay, now next is we will start making it. So we covered this thing. So basically, this is the steps that we have been discussing. You first do the total valence electrons. Next is draw the Lewis structure, count the sigma and the pi bonds, right? Next is the electron groups, determine the electron groups, match the electron groups with the hybridization type, and then make lobes for each atom, and then start making them. Okay, so we'll start doing it now. We have here, first of all, we will put bismuth in the middle. Let's put here bismuth in the middle. And then so sp3d2, sorry, this relates to octahedral shape. And this one relates to tetrahedral. So very important, you get the shapes also. Now, when we talked about octahedral, this was like a bread, a slice of bread, which was pierced. So 4 corners. So where are the chlorines going to be? So 1 chlorine here, another chlorine here, another chlorine here. Let me just make this a little bit bigger. Chlorine, chlorine, chlorine. So these are the 4 corners of the bread, and bismuth will go in the middle. Bismuth is right here. And then it's a bread that has been pierced, right? So one thing is, sorry, the other chlorine, there are how many chlorines? There are 5 chlorines. So 4 are there. The other one is here. And remember, there's a lone pair on the top of bismuth that will be occupying, the top spot. So now let's do the lobes. So we have to make 6 lobes. And so we have 1, 2, 3, 4, 5. That's with the chlorines. 5 and 6. Okay, now let's put the electrons here. So we have, this is 1 electron, 2nd electron, 3rd. Let me put this in a different color. 1 electron, 2nd electron, 3rd electron, 4th electron, and the 5th electron. So these are these over here. 1, 2, 3, 4, 5, 6, and 7. Yeah, so this is the lone pair. And then the chlorines are similarly overlapping like that. And these are the chlorines. Each of the chlorines have their lone pairs. Now, because of the space, generally, you will not see like these bonds, but you might just see only one of the orbitals overlapping. That's fine also. But, it's a good idea to always draw if the space is there. Okay, so here we have now, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, and 42. So all the 42 electrons got accounted for. We had 42 electrons. All the 42 electrons got accounted for. 42 electrons. Okay. And we have the 5 chlorines on either side of bismuth. Bismuth has a top is 1 lone pair. Okay. So that's the thing. Now, every chlorine will have the tetrahedral shape, but bismuth will have the octahedral shape. So overall molecule. Okay, if you look at the type, the bond, the type, the molecule type. So here you have A as the central atom, AXE. So there is 1 lone pair, and there are 5 chlorine atoms, and there's only 1 bismuth, and that is just what it is. So it is AX5, AX5E1. So let's look at this now in this table. In this table, AX5E1 right here, AX5E1, and the total number of electron groups. Total number of electron groups are we calculated were 5 on bismuth, right? And there are 4 number of bonding electron groups. Were 5 bonding electron groups for the 5 chlorines, and then there's 1 lone pair, and that shape is tetrahedral, but outside shape is a square pyramid. So like molecular shape is pyramid, square pyramid, but the octahedral shape is the internal shape. So we will keep with the octahedral shape because, octahedral, because that is the electron group geometry. That's what we use. So always refer to the table for the shapes, right? And that finishes this section. And if there are any questions, you can always ask. And I hope I covered everything. If there's anything left, then you can always ask me. But just follow this process to draw them, and you will never go wrong. Okay, and make a note of the handouts and the table. All right, thank you. Bye-bye.